All right, so I hope you took a few moments in class to work on this guy. But now that you've done a few of these power series transformations, you're going to see how far you can take it. So your goal on the AP test is going to be to, if you were given some rational expression like one of these guys, could you transform this power series in order to arrive at a new power series that gives the rational expression that they've started with? So that's going to be our goal. And now that you're calculus students, you have a lot more tools in your tool belt. All this algebra that we've just done, you could have done back in Algebra 2. But now let's kick it up a few notches. What about this next one? So again, if I do something to both sides of that equation to make a new power series, that's called transforming the power series. And here's two more transformations you could use. You can differentiate both sides of that equation. You could integrate both sides of that equation. And once you have a new power series, you could differentiate or integrate that new power series. So the more of these that you know, or the more of them you can find easily, the wider sort of array of starting power series you have to work with. So if I know this, I kind of knew this back in Algebra 2, that this is the same as that, then can I find a power series to represent 1 over 1 minus x squared? Whoops. Also, the faster you are at recognizing derivatives and antiderivatives at sight, the easier it's going to be to pick the tool that goes fastest. Hopefully you'll arrive at the place where you can say, oh, 1 over 1 minus x squared is the derivative of 1 over 1 minus x. And if you aren't sure, we're going to stop and we'll check it out. If I had f of x equaled 1 over 1 minus x, if I knew I was going to take the derivative, I might write that as 1 minus x to the negative 1. So f prime of x is going to be negative 1 times 1 minus x to a new exponent of negative 2 times the derivative of the inside, and that derivative is there, that negative 1. So my negative 1's cancel, and I get 1 minus x to the negative 2, which is the same as 1 over 1 minus x squared. Well, if taking the derivative of that side of the equation gets me what I want, then I'm going to take the derivative of the other side of the equation to make a power series that gives me 1 over 1 minus x squared as its sum. So here's one way to think about it. We know that 1 plus x squared plus dot 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 plus x to the n equals 1 over 1 minus x. Again, I promise that x is between negative 1 and 1. I could make the same operation on both sides. I could take the derivative of both sides with respect to x, and I would get on this side 1 over 1 minus x all squared. So let me take the derivative of the left-hand side. That's the beauty of a power series, is it's so easy to do calculus on polynomials. And there on the left-hand side, all that is a big polynomial. It has infinitely many terms, but we'll get the gist of how to take the derivative, and we'll be able to write the pattern. So I'm going to write that derivative. The derivative of 1 is 0, plus the derivative of x is 1, plus 2x, plus 3x squared, plus dot dot dot, plus n times x to the n minus 1, plus dot dot dot. Sorry, I ran out of room. I probably should have squeezed that in. And notice I would still have to keep going. This polynomial on the left is going to have infinitely many terms still, even though it has one term less than the polynomial I started with. So just some notation stuff. This term here that I wrote that has the n's in it, that's called the nth term or the general term. So if I were asked to use a nice notation to write that polynomial, I would say that I'm adding together polynomials. I'm adding together the infinite number of terms in a polynomial, and the terms look like n, x to the n minus 1. Nope, that should be infinity. So this is called the general term, but you can write out sort of a typical thing to find on the AP test is they ask you to write out the first three terms and the general term. So it turns out just coincidentally that's what I did. I wrote out the first three terms longhand, and I wrote an expression for the nth term, or the general term. You probably guessed what's coming next. I can also integrate term by term if I know that. I started with a different series this time. This guy, that's supposed to be 1 over 1 minus x. That means that I'm using negative x as my multiplier. So I know that 1 minus x plus x squared minus x cubed plus dot 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 negative x raised to the n equals the natural log of 1 plus, oops, no, I know that equals 1 over 1 plus x. And I want a series to represent natural log of 1 point x. Look at this. The antiderivative of 1 over 1 plus x is natural log of x. So I can find the antiderivative of both sides. On the left-hand side, that's going to be 1 over, natural log of 1 plus x. And on the right-hand side, I can integrate term by term. So I'm going to integrate 1 to get x. This is going to be negative x squared over 2 plus x cubed over 3 minus x to the 4th over 4 plus dot dot dot. Here's the tricky part. Can you write the nth term? Do you get what the pattern is? So yeah, if we're integrating a polynomial expression, what am I going to do? I'm going to increase the exponent by 1. So it's going to be negative x raised to the new exponent, n plus 1, divide by the new exponent. That's my expression. It's a power series that is equivalent to, equal to, the natural log of 1 point x. So let's try this one. Here I have a function f of t that's equal to 4 over 1 plus t squared. The next part is also true, but it doesn't apply to part A. Find the first 4 terms, I should say find the first 4 terms, and the general term for the power series expansion of f of t about t equals 0. So that just, the about t equals 0 means I'm not going to shift it. I'm not going to use t plus something or t minus something. I'm going to start with a power series that I know. All right, so what's the one that we know? It would be 1 plus x squared plus x cubed plus dot 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 plus x to the n equals 1 over 1 minus x. What am I going to have to do to both sides of this equation so that my right-hand side turns into 4 over 1 plus t squared? So, sorry, I probably should have started with t's. So I'm going to make a variable change. Everywhere I see x, I'm going to replace it with a t. I'm going to have to multiply the right-hand side by 4 to get that new numerator. So that means I'm going to multiply every term on the left-hand side by 4. And then how am I going to turn that minus x into a plus t? Everywhere I see x, I want to replace it with negative t squared. So that's supposed to be that number down there, 1 minus x, the thing getting subtracted from 1 is supposed to be my common ratio. That means the thing that's supposed to be my common ratio is going to be negative t squared. So I'm going to replace all of my x's with negative t squareds. I'll do them times 4 on the next step. So I'm going to replace all the x's with negative t squareds. It's going to be 1 minus t squared plus t to the 4th minus t to the 6th plus t to the 8th minus dot 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 plus negative t squared to the n is going to equal 1 over 1 plus t squared. And now I almost have my series, I'm supposed to have a 4 in the numerator, so I'm going to go through and I'm going to multiply every term on the left by 4 so that I can multiply the right-hand side by 4. This is going to give me 4 over 1 plus t squared. This is going to be 4 minus 4t squared plus 4t to the 4th minus 4t to the 6th plus dot 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 plus, this was 4 times negative t squared to the n. So that is the first 4 terms, 1, 2, 3, 4, and the general term for the power series expansion of 4 over 1 plus t squared. All right, so part B asks me to find the first 4 terms and the general term for g of x. And g is supposed to be the integral from 0 to x of that same f function that we used before, which is 4 over 1 plus t squared. So you can write this integral, they wrote it for you, and what we need to notice is that anytime we have the polynomial, well, it's not polynomial, every time we have the rational function 4 over 1 plus t squared, it is totally mathematically legit to replace it with that power series you wrote in part A. So that's going to be the same as the integral from 0 to x of 4 minus 4t squared plus 4t to the 4th minus 4t to the 6th plus dot dot dot. I'm going to write the general term because it's going to be easier to find the antiderivative if I can look at this pattern. We wrote, what did we write? We wrote 4 times negative t squared to the n. Technically that all needs to go inside some kind of big grouping symbol with a dt here. And I can integrate this polynomial term by term. Technically there are infinitely many terms in this polynomial, but that's why I've only been asked to write the first 4 terms and the general term. So that's going to be, I need an antiderivative, so I'm going to start the antiderivative of 4 is 4t minus, this is going to be 4t cubed over 3 plus 4t to the 5th over 5, oops, minus 4t to the 7th over 7. So that's the first 4 terms, the first 4 non-zero terms, and the general term. So I'm going to go dot, dot, dot. I'm going to have to figure out what it would look like if I took the antiderivative of that. So I should just clarify. I see it's a little sloppy the way it got written. That was a negative t inside the parentheses. So I have 4 times negative t to the 2n. So that's going to be 2n to the, okay, so that's t to the 2n plus 1. I'm going to divide by the new exponent, 2n plus 1. And I'm going to need the 4. And my terms are changing sign. The first term was positive, the second term was negative, the third term was positive, the fourth term was negative. So I want all the odd terms to be positive. I want all the even terms to be negative. So let's see what we got here. It's negative 1 to the, I'm going to need to evaluate that from 0 to x because those are the limits on the original integral. And now I can do, so essentially f of b, capital F of b minus capital F of a. It's an x up top. But every one of these terms has a t multiplying, which means when I plug in 0, my f of a is going to be 0. So I'm going to end up with 4x minus 4x cubed over 3 plus 4x to the 5th over 5 minus 4x to the 7th over 7 dot dot dot. That's 4x to the 2n plus 1 over 2n plus 1, and that's a negative 1 to the n. Final answer.